don't think this is going to take more than about 10 or 15 minutes for me to go through. Okay? So, adding vectors by scale at any angle. So when I say by scale, I mean by scale drawing, and I mean with a ruler and a protractor. Okay? Now remember I ranted about this yesterday. You can only use Pythagoras when the vectors are perpendicular to each other. Do you have that on your page? Okay. I cannot stress this enough. You can only use Pythagoras when the vectors are perpendicular to each other. Charlie, you plugged in on one ear there? Yeah? Think I'm plugged in? Okay? You cannot use Pythagoras when they are like this or like that. They must be perpendicular. What's going to happen if you do that on a test? Frowny face. How, Megan?
The null has to go like
That's a good idea. Yeah, but how do I draw that on a test, right?
like a frown. Yeah.
It's like a little sticker. You ruined it.
Correct it. Just one line, just down. There you go.
That's not bad, actually.
Yeah, I'd rather say. Angry eyebrows. Oh, more.
Yeah,
Oh.
I have to make it more dramatically like down.
More dramatically down. Like grumpy cat.
Yeah. There, that's so
A frowning. Do not do it. You took a picture? Yeah. Do you think all this chatter will help you remember not to do this? I really hope so. I'm doing my very best here. I will be kind of disappointed. Okay. Vectors that are not perpendicular must be added by using scale diagrams. The result is then found by ruler and protractor. Remember from yesterday? How do we arrange them? Tip to tail. I'll call this one V1, V2, just for like vector 1, vector 2. Right? Where do we draw the resultant? Always from where you start to where you end. Always. I try not to use the word always because it quite often gets you into trouble. But this isn't always. Always, when adding vectors, draw from start to end. Now, where do we draw the theta sign? Where do we measure the angle? At the beginning. At the beginning. No, you can measure it, Riley, right? You can measure it with a protractor. Okay? All right, so I think you have an example coming next. What do you have? I see people writing here. Let's add the following vectors. Okay, so we got 10 kilometers, north 30 east, plus 8 kilometers at west 15 north. I'm going to sit down and I'm going to get my ruler and protractor out. You should too. Ruler, protractor. Anyone need a ruler or protractor? Okay, so 10 kilometers, north 30 east, 8 kilometers west 15 north. So the first thing you need is a scale that matches both. Something like 1 centimeter equals, what do you think? Maybe 1 kilometer? 1 or 2. I'm going to go with 1, I think. Now, I've given you a fair bit of room, but you still have to think ahead about where to start. Okay, so I suggest you do a little sketch, kind of in the corner. Okay, so north 30 east is going to be north 30 east like that, and then west 15 north, west 15 north. So it's going to be kind of like this. So should you start in the top left-hand corner? No, you got to plan ahead a little bit. I'm going to start way down here. Okay, so I got north. So draw a reference line that gives you north. If you want to draw the four-way Cartesian thing, that's fine. It only needs to be just a smidge long. Okay, so that's my reference line for the first one. North 30 east. So I'm going to bring in my protractor. I'm going to put 0 at north. At the bottom, north 30. Little tick mark. Rid of the protractor. And it's going to be 10 kilometers long, so I need 10 centimeters. Everybody with me so far? I recommend wait until you're done to put the arrowhead on because it kind of can mess up your measuring a little bit. If you've done it already, that's okay. A nice sharp pencil will help. If you're using a pen, I strongly suggest you get yourself a pencil. Okay, now from here I got to go west 15 north. Should we draw another reference line? We should. Another little one that goes west. Now I'm lucky because I can draw a straight line and it matches the screen, right? So it goes like perfectly west. You might need to, it's probably a good idea to, you might need to put your protractor on sort of upside down and do this kind of thing. Right? Match that up against the 30 and then make a little tick mark and go west that way, right? Like you want to make sure that your west has to be 90 degrees to your original north. Okay? If you don't get that, that's fine. It's just that you're more likely to introduce some error. Okay, so now I'm going west 15 north. So put 0 at west. Come on, I want the rotating. There we go. Okay, 0. Put it on there. Now I'm going 15. Right there. Oh. Okay, Drayson, you need to watch now. No visiting. Learning time. West 15 north. So I'm going to go 8 kilometers, right? So that's going to be 8 from there. Is it important you take care with your ruler and protractor? Yeah, you got to just be a little bit, cautious, a little bit slower. Don't rush. Take your time. Okay? Okay, and again, I would suggest don't put your arrowheads on just yet because it kind of messes up your measuring, right? If you want to label them, that'd be a good idea, right? That's one way for me to see that you know what you're doing. So this is the 10 and this is the 8. Okay, now what do I do? Yeah, measure the result. I'm going to draw it first. My process is slightly different because I've got slightly different tools, but okay, so as neat as you can, there's your result, and then you actually measure it. Okay, so get in your ruler there. I measure mine to be 11.1. Okay, remember, what's the plus or minus rule?
Oh, I used to difference.
Plus or minus 0.3 centimeters, which means you can be anywhere from 10.8 to 11.4. One of your angles is probably wrong. Say again, Colin? You're still going to get 11.1. You're just going to get a centimeter that you're going to have to multiply by to get the 11.1, right? Notice that I put my answer in kilometers because that's what it is, right? 1 centimeter equals 1 kilometer, so 11.1 kilometers. Am I done? No. I need everyone pens down watching because here's the most common mistake. Okay? Here's what kids do. They bring in their protractor and they do this. Just give me a second. And they measure this. And they say the angle is 48 degrees. What's wrong with that? It's what? What do you mean by that? I think you're on the right track. Yeah, it's not being measured from north or east or south or west, right? You have to measure your final answer from north or east or south or west. So you have to put that final protractor like this on that original reference line. Okay, you've got to measure from north, because how are you going to say 48 degrees from the other one? Right? That doesn't make sense. It's not easy. You've got to measure from north. Okay, so this is going to be, I don't quite have it in the right spot. I would say 15 degrees. So that's going to be north, 15 west, isn't it? And again, plus or minus 3 degrees. I took the protractor. I took the protractor. Right, it's not being very nice to me. There we go. Took the protractor and I measured from north. Right, north, 10, 15 degrees west. Okay? Say again? Remember, the final answer has to be, the final vector description has to be from north or west or something like that, right? I don't care about this little guy in here. Has no effect on anything, right? This is the angle here that I care about. I have to measure from north or east or south or west or something like that. Okay? Give me the nod of agreement. Okay. You try this one while I go do my attendance. Okay, so we got 80 kilometers per hour and 35 kilometers per hour. How many people noticed that these were velocities? I quite often see kids just ignore the per hour. They don't know what to do, because how can a centimeter be a kilometer per hour? It can. It's a model. Okay, so don't worry about that. So I'm going to go with 1 centimeter equals, what'd you guys go with? 10?
Yeah.
10 kilometers per hour. Okay, draw your sketch. Figure out what it's going to look like. South 40 east means south and then 40 to the east. So the first one is kind of like that. Right? South 40 to the east, and then east 75 north. So east is to the right, east 75 north. So kind of like that, right? This one's a lot shorter though, isn't it? Right? So it's going to kind of be like that. So where should I start? I'm going to start in the top left. Draw a reference line. South 40 east. Draw a reference line for south. Doesn't have to be too big. South 40 east. Oh, I need my protractor. And I need a ruler. Okay. South 40 east. So put your protractor at 0 at south. At the top now, because that's my south, right? South 40 east, so I'm going to 40, right? Right there. How long do I draw the line? Come on, you. 80 kilometers an hour, so I'm going to go 8, right? From there, okay, 80, so 8 long. I went a smidge long. It's hard to do up here. Okay, did you do that first? Yes? Everyone's good? Okay, so from there, from the bottom here, Colin and Drayson, watch. Here's the learning part. east 75 north. So put your 0 at east. There's a 0 at east. And I'm going to go 75 north. So like there. Remember, each tick mark is 1. 75 is there. So I'm going to put my little right there. Get it out of the way. Come on. Okay. Then ruler 35. So only 3.5, right? Oh, that's a big mistake for me, because now when I change the size of my ruler, what happens? I change the size of the scale, don't I? I'm thinking if I go Control Z, yes, it goes back to its normal, to its regular shape. Okay, 35. Yeah, they should. I should be able to lock it in, right? So I just got to think here so I get it the right. Okay, I got my 0 at the wrong end, but I'll deal with it. I'll go from 6, 3.5, so that's going to be 1, 2, 3.5, right to there. I'm a little bit too long again. Okay, that's my second one. So I'm measuring from where to where? Original start from there to there. Right? Okay, and then how do I find it? Bring in your, oh wait, bring in your ruler. Come on, rotate you. So I'm getting like about 6.9. I was a bit long on my other one, so yeah. I got 6.9. Again, you guys can do this in your head. You don't have to ask me. It's plus or minus 3 millimeters. So 6.6 all the way to 7.2. And in fact, I actually do a calculation. I don't do it by hand. I got the exact right answer. So 6.9 plus or minus 3 millimeters. So that's going to be 669 kilometers per hour, right? Okay. And then bring in protractor. Does it matter that that changes?
No.
It doesn't actually. No, it doesn't. Okay, now here's the problem. Where do I measure from? You measure at the start, and you have to put 0 at one of the cardinal points. You got to put 0 at north or south or east or west, right? So I'm going to bring it in, and I'm going to put it right there so that 0 is south. And my resultant is way over here. It looks like 65, 66. I'm going to say 66 degrees. So that's going to be south, 66 east. Now, what if you measured this way? Is that okay? Yes, it's perfectly fine. As long as there's 90s here at 0, and then this is east. So this is going to be east, 10, 20, 24. East, 24 south. Are these the same? Yes, they are equivalent. Both are correct. You'll get all the marks for it. They are the same. How do I know? Well, I write them both down. But if I take these numbers and add them up, what should they add up to? 90 degrees. Okay, so you might see a practice question or something or other in a book or something or other, and you might have a different angle. All you do is take your angle and match it up with the other one at 90 degrees and see if it's the complement, right? Okay, so either of those is fine. Sure. So you don't have anything on the back, do you? Okay. You just wrote on the back. How about I just make one up and you guys try it on loose leaf? Do you want to do that?
Yeah.
Okay. Let me just make up one here. Yeah, there you go. 40 newtons at south 30 east and 65 newtons at north 15 west. 40 newtons, 65 newtons. Scale is 1 centimeter equals 10 newtons, right? South 30 east. Draw a reference line. Oh, that's no good. South 30 east. From there, I'm going to go south, put my 0 at south, and I'm going to go 30 east from the top. That's where I'm going to go. So 0, that's south, 10, 20, 30. Come on, right there. Ruler. 40 newtons, so I went 1 centimeter equals 10, so it's going to be 4 long, right? Oh. Now, does this matter yet?
No.
Because I haven't started yet, right? But I'm just going to put it back to the original one. That way I know it goes back. Okay, so I need from here. Okay. Four. Oh, and I gotta do it from the top, right? It's 30 degrees, that's why I missed it. Okay, 40 newtons. So 4 like that. Then from here, you're going to draw another reference line, north 15 west. So bring in the protractor again, north 15 west. So I got to rotate it all the way around. From there, north 15 west, north 10, 20, 15 is going to be like there. And it's going to be 65. From there, and I'm going to go 65, right? 6.5 to there. And where's my resultant from? From where I started to where I end. It's really short and it's almost straight up and down, right? Oh, I didn't put an arrowhead on it. Okay, and then measure. I get like about 2.8. So we're going to be at 28 newtons. Again, plus or minus 3. 28 newtons. And my angle, rotate it around. So now what do you do if the line's not long enough? Like my line doesn't match up with my protractor here. What do you do? You can extend the line lightly with a pencil, right? So you can extend the line. Fortunately, I have this ability on my protractor. Yeah, I can't. But I can't really extend my line very easy, so I'm going to do it like this. So I get like about 7 degrees. So that's going to be north 7 east. Okay?